Artificial intelligence is transforming nearly every industry. From writing code to designing systems, AI tools are becoming more capable every year. Naturally, many students are asking an important question: which engineering major might be most vulnerable to AI disruption? Let's be clear: AI will not completely replace engineers. Engineering is fundamentally about judgment, responsibility, and solving real world problems. However, some engineering roles rely heavily on routine analytical tasks, which are exactly the kinds of activities AI excels at. Today, we are going to examine several engineering fields where certain tasks may be increasingly automated, and what students can do to stay competitive in the age of AI. Number one, computer engineering and software oriented roles. Ironically, one of the fields most affected by AI is software development itself. Large language models now can write code, debug programs, and even generate entire applications. Tools integrated into platforms such as GitHub Copilot already assist millions of developers. Entry-level programming tasks like writing standard functions, debugging syntax errors, or translating algorithms into code are becoming increasingly automated. However, high-level responsibilities remain deeply human. System architecture, cybersecurity strategy, and complex software integration still require experienced engineers who understand the broader technical and organizational context. In other words, routine coding may decline, but software engineering leadership will remain essential. And number two, industrial engineering. Industrial engineering focuses on optimizing processes, logistics, and operational efficiency. These tasks often rely on mathematical modeling, simulation, and optimization. These are areas where AI and machine learning are exceptionally powerful. Advanced analytical platforms can now automatically analyze production data, identify inefficiencies, and recommend optimized workflows. AI-driven supply chain management systems already assist companies with forecasting demand, managing inventories, and scheduling production. As a result, traditional optimization tasks may become increasingly automated. But industrial engineers who specialize in human-centered systems, sustainability, and complex organizational design will continue to play a critical role. Number three, electrical engineering in routine design work. Electrical engineers often design circuits, control systems, and electronic components. Many aspects of circuit design involves repetitive calculations and standard design templates. AI-powered design tools can already generate optimized circuit layouts and perform automated testing simulations. For example, modern electronic design automation software can rapidly evolve thousands of circuit configurations and select the most efficient design. However, cutting-edge areas such as renewable energy systems, power grid resilience, and advanced semiconductor development still require deep engineering expertise. Number four, structural engineering and routine design. In civil engineering, structural analysis often involves solving well-defined equations and applying standardized codes. AI-assisted design tools can now automatically generate building models, perform structural simulations, and optimize material usage. But infrastructure projects involve far more than calculations. Engineers must address site conditions, construction constraints, environmental impact, and safety risks. Because structures affect public safety, human oversight and professional licensure will remain indispensable. And now let's talk about fields that are less likely to be replaced. Interestingly, engineering disciplines that interact heavily with physical world tend to be less vulnerable to AI automation. For example, civil engineering, environmental engineering, and mechanical engineering. This field involves field inspections, construction management, regulatory compliance, and real-world problem solving. AI can assist with analysis, but physical infrastructure still require human engineers to design, oversee, and maintain it. The big change is not replacement, it is augmentation. AI will eliminate some repetitive technical tasks, but it will also allow engineers to focus on high-level responsibilities, such as system integration, innovation and design thinking, interdisciplinary problem solving, and leadership and project management. Engineers who learn how to use AI as a tool will become dramatically more productive. So, how should engineering students prepare? If you are studying engineering today, there are several strategies to future-proof your career. First, focus on fundamental engineering principles: physics, mathematics, and system thinking. These foundations will remain variable regardless of technological change. Second, develop interdisciplinary skills. Engineers who understand policy, economics, sustainability, and public infrastructure will have a broader impact. Third, build real-world experience through internships, research projects, and hands-on work. And finally, learn to collaborate with AI tools rather than compete against them. Like it or not, artificial intelligence will reshape the engineering profession, but it will not eliminate the need for engineers. Routine calculations and standard designs may increasingly be automated. However, engineering ultimately requires creativity, judgment, and responsibility. These are qualities that machines cannot fully replicate. The engineers who thrive in the AI era will not simply follow formulas. They will design systems, solve complex problems, and guide technology towards improving society. And those engineers will remain indispensable. Thanks for watching, and I'll see you in the next one.